Hello students, today we will discuss hybridization, geometry, shape and planarity related concept. We know that hybridization or number of hybrid orbitals is equal to sum of sigma bond and lone pairs. Okay, here geometry means orientation of this sigma electrons and lone pair electrons in 3 dimension is called geometry. Whereas shape means orientation of the all atoms in the molecule in 3 dimension is said to be shape. So we are excluding here lone pairs, only sigma electrons orientation we are considering, or all atoms in 3D space we are considering. And planar means orientation of atoms in 3D space. Orientation of the 2D space, not 3D, only 2D space. So in 2D space or in same plane atoms we are considering. If all the atoms are present in same plane, then that molecule is said to be planar. Coming to the sp hybridization, here number of sigma bonds are 2. 1 plus 1, 2. So then that is sp hybridization. These are present in same plane. So that's why, so that molecule is said to be planar. And these are located so in linear one line. So that's why the shape is said to be linear here. Geometry is said to be linear here. Next, sp2 hybridization. If number of sigma bonds are 3, so 1, 2, 3, so then that is sp2 hybridization. So the geometry of this sp2 hybridization is trigonal planar. Since all the atoms are present in same plane, so this molecule is said to be planar. If number of sigma bond is 2 and lone pair is 1, so 2 plus 1 3, once again sp2 hybridization. So then here instead of one sigma bond, one lone pair is present. While assigning the shape, we have to exclude the lone pair. So geometry is trigonal planar only, but shape is V shape. We have to exclude the lone pair while assigning the shape. So this shape is said to be bent shape or V shape or angular shape. Since all three atoms are present in the same plane, so this molecule is planar. Remember one thing, when atomicity is 2 or atomicity is 3, then the molecule are always planar. So here three atoms are there, so then planar. So next, coming to the sp3 hybridization. Suppose all are sigma bonds. So 4 are sigma bonds. So then sp3 hybridization and the geometry is tetrahedral. Here with respect to this central atom, three atoms are like down, tripod stand like structure here, and one atom is above the plane. So this shape is said to be in tetrahedral shape. And here two atoms, central atom and this above atom are out of the plane. Three atoms are present in same plane. If two atoms are out of the plane, then that molecule is said to be non-planar. If sp3 hybridization contains one lone pair and three sigma bonds. Here sigma bonds are 3 and one lone pair. 3 plus 1, so 4. So sp3 hybridization. So that lone pair placed like this. So then the residual so shape is said to be pyramidal shape. Three atoms are present in same plane and one is above the plane. So then this molecule is also non-planar and shape is pyramidal shape. Geometry is tetrahedral only. Why? Because sp3 hybridization. Next, two sigma bonds and two lone pairs. So that is also sp3 hybridization. Geometry is tetrahedral only, but shape is here two bonds, sigma bonds are present on plane and V shape. So next, two lone pairs are present above the plane and below the plane. The shape of this molecule is bent or V shape or angular, and this molecule is also planar. This molecule is also planar. Why? Because atomicity is 3, so that's why planar. Next, sp3d hybridization. sp3d hybridization. So 5 sigma bonds are there means then that is sp3d hybridization. Here orientation of these sigma bonds are 3 sigma bonds are equatorial positions, means on the plane. So like this, right hand side 2, left hand side 1, and 2 are, one is above the plane, another one is okay below the plane, axial. These are said to be axial bonds, 2 axial bonds, 3 equatorial bonds. And the geometry is said to be trigonal bipyramidal. Since here 2 atoms are out of the plane, so that's why this is non-planar. If number of sigma bonds are 4 and one lone pair, so then 4 plus 1, 5, sp3d hybridization once again. So when you are excluding this lone pair, so the residual shape is said to be seesaw. And remember one point in sp3d hybridization, so lone pairs should be placed in equatorial position only. Why? Because to minimize the repulsions between the lone pair and okay bond pair. If lone pair is okay placed on axial position, here bond angle is okay 90, so closer bond this lone pair and okay bond pair will be very closer, repulsions will be maximum. If it is okay placed in equatorial position, here bond angle is 120, means lone pair and okay bond pair little bit okay far away from each other, so that's why minimum repulsions will be there and stable, more stable relatively. So that's why equatorial this lone pair should be placed in equatorial positions. Next, if two lone pairs and 3 sigma bonds, two lone pairs and okay 3 sigma bonds in sp3d hybridization only, so orientation of this lone pair placed in okay equatorial position and remaining are okay sigma bonds. So when you are okay excluding this lone pairs, the residual shape is said to be T shape, T shape. So T shape. Since here two atoms are out of the plane, this molecule is said to be non-planar. Next, if the molecule contains 2 sigma bonds and 3 lone pairs, so 2 plus 3, so 5 sp3d hybridization. So this lone pair should be placed once again in equatorial positions, 3 lone pairs in equatorial position. The residual shape is said to be linear, and all these atoms are present in single plane, so that's why this is planar. Sorry, I wrote here non-planar, but it is okay, planar. Next, sp3d2 hybridization. Okay, number of all are sigma bonds. 6 sigma bonds means so that is okay, sp3d hybridization. So those are okay oriented. So 4 bonds, sigma bonds in same plane and means equatorial position, and 2 are okay axial position like this. So this geometry is said to be octahedral. Since 2 atoms are okay out of the plane, this molecule is said to be non-planar. Next, if one lone pair and 5 sigma bonds are there, means then that is also sp3d2 hybridization. Here lone pair is okay placed down. So when you are excluding this lone pair, so the residual shape is said to be square planar. So means these 4 atoms are present in square shape, and with respect to this top atom, when you are joining these corners, you will get the square pyramidal shape. Here one atom is out of the plane, so that's why non-planar. So if two lone pairs are present in sp3d2 hybridization, this is the shape. So lone pair above the plane, below the plane. So the shape is said to be square planar. Okay, since all the atom, so 5 atoms, including central atom, present in same plane. So that's why this molecule is okay planar. When you are okay considering the sp3d hybridization, so here total, so 7 bonded electrons, okay, sigma bonds. So 5 are present in equatorial position and 2 are okay axial positions. So 2 are axial position. So this geometry is said to be pentagonal bipyramidal. Since 2 atoms are okay out of the plane, so this molecule is non-planar. Next, here if one lone pair is okay present in the pentagonal bipyramidal, so that should be taken in equatorial position. So then the residual geometry is said to be distorted octahedral. Distorted octahedral. Just you compare these two. Here one lone pair is okay present here. That lone pair repels the this bond pairs here. So that's why that is distorted. It will be turned distorted octahedral shape will be obtained. Once again non-planar. Why? Because two atoms are out of the plane. Next here pentagonal bipyramid. Pentagonal planar. So if two lone pairs are present in pentagonal bipyramidal, those are placed in axial positions. So all 7 atoms, not 7, 6 atoms are 6 atoms are present in same plane. So that's why this molecule is okay planar. So the shape is a pentagonal planar. So this is about the hybridization, geometry, shape and planarity concept. Thank you.